Suppose matrix A is a 3 by 3 matrix such that matrix A times the vector negative 30, 18, negative 6 equals the vector 5, negative 3, 1. Find an eigenvalue of matrix A. Notice the given equation fits the eigenvector equation matrix A times vector x equals lambda times vector x, where lambda is an eigenvalue of matrix A. This also indicates that the vector 5, negative 3, 1 is some scalar multiple of the vector negative 30, 18, negative 6. So we might be able to determine lambda just by inspection, but if not, the form of the equation indicates that vector x is equal to the vector negative 30, 18, negative 6, and lambda times vector x is equal to the vector 5, negative 3, 1. So if we need to, we can substitute vector x into the second equation and solve for lambda. So let's go ahead and show that. That would give us lambda times the vector negative 30, 18, negative 6 equals the vector 5, negative 3, 1. Maybe from here we can determine that lambda is going to be equal to negative 1/6, but if we still can't, we can write the vector equation as a system of equations where the first equation is lambda times negative 30 is equal to 5. The second equation is lambda times 18 is equal to negative 3. And the third equation is lambda times negative 6 equals positive 1. We will look at the same value for lambda from each equation, so we can simply pick one equation and solve for lambda. For example, if we solve this last equation for lambda, we would divide both sides by negative 6. Lambda equals 1 divided by negative 6, or negative 1/6. And we'll get the same result from the other two equations. Let's just go ahead and show that. For the second equation, if we divide both sides by 18, we have lambda equals negative 3 divided by 18, which is negative 1/6. And for the first equation, if we divide both sides by negative 30, we have lambda equals 5 divided by negative 30, which is also negative 1/6. So to answer the question, an eigenvalue for matrix A is lambda equals negative 1/6. I hope you found this helpful.